In the first lecture of our GAST1020, that is Buildings and Air Handling course, we're going to discuss phase transition of water. And that means we're going to look at how water goes from steam to liquid, which is water, to ice, which is its solid state, and what kind of heat is added or removed, and what quantities of heat are added or removed. So the questions that we are going to work on are: how much heat is required to boil 1 pound of water, for example, and how much heat is removed to freeze 1 pound of water, what is enthalpy, and what is latent heat versus sensible heat, and so forth. For this purpose, we are going to use our graph here. This graph always is going to always represent 1 pound of H2O. Okay, so when I say, for example, this is your y axis that represents the temperature. When I say the temperature of the H2O that we're working on went from 50 to 100, I mean 1 pound of H2O was heated from 50 to 100. The x-axis, on the other hand, represents the added heat or heat content. So this point here, 0, means that we have not yet added any heat. Whatever that 1 pound of H2O we had at the beginning is still carrying its initial heat content. Adding 100, 200, up to 1400 BTUs is going to be graphed here. So again, just to emphasize, if I say we go from point A to point B, what that means is for 1 pound of H2O that we're working with, we have added heat. If we go from B to A, we have removed heat. That's according to the axis here. So B is roughly, here, and A is here. And the difference between those 2 points is going to be the heat added or removed. On the other hand, and similar to that, is point A to point B here, is the either adding temperature, so increasing temperature, or decreasing temperature. But again, don't forget, this is 1 pound of H2O. Okay, so in this case, we're going to start working on our examples here. So let's have a look at this diagram with a starting point of 1. And this starting point of 1 represents our 1 pound of water. Don't forget, 1 pound of water, H2O I should say, at 0 degrees Fahrenheit, or it's the same as minus 17.8 degrees Celsius, and we haven't yet added any BTUs to it, therefore it is 0. When we're working on our problems here, it is important for us to maintain, this, to observe this axis and the value on it. So right now, because what that 1 pound of H2O is at 0 degrees Fahrenheit, it means it is in solid state. 0 degrees H2O is ice. So that's what it is. So that's your first point. The question is, what happens when we start adding heat to that 1 pound of ice that is at 0 degrees Fahrenheit? Sometimes I will not say ice, I will just say H2O, and you are supposed to know that H2O at 0 degrees Fahrenheit or 5 degrees or 15 degrees Fahrenheit is in the form of ice. Let's go and see what happens. This is what's going to happen. When we added that heat, starting from 0 here to the point where our H2O, again, 1 pound of H2O has reached 32 degrees Celsius, or sorry, 32 degrees Fahrenheit, we were adding heat and increasing temperature. Okay, I need you to remember, we were adding heat and increasing temperature. Now, because this temperature change is something we can detect, it is something we can sense, we call the heat that caused it sensible heat. So that's your sensible heat, meaning when we added 16 BTUs of sensible heat, when we added 16 BTUs of sensible heat, okay, and sensible heat means that there is temperature change, but no change of state. You should notice that between point 1 and point 2, the H2O stayed in the form of ice and it simply heated up. Okay, so 16 BTUs of sensible heat increased our temperature. So we had a delta T, meaning change of temperature, by 32 degrees Fahrenheit, because we went from 0, according to this guy here, 0 degrees Fahrenheit to 32 degrees Fahrenheit. That's what this whole operation represents. You can see how changing temperature of ice 1 degree Fahrenheit requires half a BTU. That's what it is. For every 32 degree Fahrenheit change, we use 16 BTUs, half the amount of the 32, and therefore the rule or the statement is that for every 1 degree Fahrenheit change, we need half a BTU. That's enough for ice. But I think you can remember the definition of a BTU. The definition of a BTU is, so BTU equals to the amount of heat required to raise the temperature of 1 pound of water, okay, not H2O, water, liquid H2O. That is liquid H2O. Okay, so 1 pound of water by 1 degree Fahrenheit. So when you're dealing with water, change of 1 degree Fahrenheit requires 1 BTU. That's the definition of the BTU. But when you're working with ice, changing of 1 degree Fahrenheit requires half a BTU. So ice is different than water in terms of how much BTUs it requires to change 1 degree Fahrenheit. And we're going to see that steam is also at the same relationship with the temperature or Fahrenheit and BTUs. Steam requires half a BTU to change its temperature by 1 degree Fahrenheit. Okay, so we are at point 2. What would happen if I increase the heat content, if I just add heat to that ice that is at 32 degrees Fahrenheit? That's the question you need to ask yourself right now. You need to think about it. I will move forward. You can pause the video and think about it. What will happen to that 1 pound of H2O at 32 degrees, which we agreed that it is still in ice phase when we move forward. All right, so what will happen is by adding that heat to the point where ice is at 32 degrees Fahrenheit, we caused a change of state. Water, or H2O, in its solid state at point 2 turned into H2O in its liquid state at point 3. Meanwhile, we were adding heat, but there was no temperature change. And that's what we call latent heat. So again, this is all about 1 pound of water. So adding latent heat will cause no temperature change. That's why it's latent, it's hidden. We cannot detect it. There is no way to detect that heat being added except for its second effect, which is cause change of phase. As simple as that. It is the opposite of sensible heat. Sensible heat is heat we can sense, or at least our thermometers can sense. It causes delta T, temperature change. So now we are at point 3 here, and we're trying to figure out what will happen when I keep adding more heat to this substance, which is 1 pound of H2O. Now it is water at 32 degrees Fahrenheit, 100% water. What will happen to it when I keep adding heat? That's an important question. You can you can pause the video and think about it. I'm going to move to the next phase here. What will happen is, while we add that heat, temperature will rise. Okay, so that defines the temperature as sensible. Again, temperature is sensible when we can sense it, and latent when we cannot sense it, meaning there is no temperature change. And as you can see, there is the pure definition of BTU right here. So by adding here, by adding 180 BTUs, we caused a temperature change between point 3, that is 32 degrees Fahrenheit, and point 4, that is 212 degrees Fahrenheit. This temperature change, delta T, is 212 minus 32, that's 180 degrees Fahrenheit. So adding 180 BTUs caused a temperature change of 180 degrees Fahrenheit. That's the definition of a BTU to start with, because the H2O that we're talking about between 0.3 and 0.4 is in its liquid form. So in its liquid form, it is simply your water, and BTU is the amount of heat required to change 1 pound of water temperature by 1 degree Fahrenheit. That's it. Now, the next step obviously is to go beyond point number 4. At point 4, we're 100% liquid, but we're also at 212 degrees Fahrenheit. That is the boiling temperature of water. What will happen if I keep adding more heat? What will happen if I keep adding more heat to that 1 pound of H2O at 212 degrees Fahrenheit? What will happen is it will take a whooping 970 BTUs for that 1 pound of water to turn from 100% liquid in at point 4 to 100% steam, meaning gas, at point 5. Is this sensible heat or latent heat? Well, do we sense any temperature change? No, there is no temperature change. Temperature is staying at a constant 212 degrees Fahrenheit. So if there is no temperature change, we're going to call this latent heat, obviously. So it is important now to do one more step that is going beyond 0.5, where it is 1 pound of steam, 100% steam, at 212 degrees Fahrenheit. What would happen if I went beyond that point? Well, adding heat beyond 0.5 will only increase the temperature of steam. Okay, you don't have liquid to boil, so it will just add the temperature of steam. And because the temperature is increasing, so some kind of thermometer that we're using to measure the temperature is sensing the temperature change, therefore we call it sensible heat. So this is everything you need to know in terms of how water is or how water does change its phase. Two things are of importance. Number one, you have two horizontal lines. This is one horizontal line between 0.4 and 0.5, and there is another horizontal line between 0.2 and 0.3. Both horizontal lines are phase changes. They represent phase changes. The first one between 0.2 and 3 is staying at 32 degrees Fahrenheit. So that horizontal line is either the melting line or the freezing line of 1 pound of water. And then the line between 0.5 and 0.4 is the line that we call vaporization or evaporation. So I'm going to call it vaporization, and it takes 970 BTUs of latent heat to vaporize 1 pound of water or to condensate 1 pound of water. Obviously, when you're condensating that 1 pound of steam, you're taking away 970 BTUs of latent heat. And when you are freezing, you're taking away 144 BTUs. Those two numbers, those 144 per pound and 970 per pound, are not going to change. Those are constant numbers. They are per pound of H2O. So when I ask you questions such as how much heat is supposed to be removed from 1 pound of water at 32 degrees Fahrenheit to freeze it completely, the answer would be this here, 144 BTU. And similarly, how much heat do we need to remove from 1 pound of ice to completely turn it into water? The answer is also this constant here, that is 970 BTUs of latent heat. All right. So I think it is worthwhile mentioning that melting and freezing are the opposite. Vaporization is the change from liquid to gas, and evaporation is vaporization from the surface of a liquid. Not very important. I will always use vaporization and evaporation interchangeably. This is not a important thing for the purpose of this course. Boiling is vaporization from within as well as from the surface of the liquid. All right, so these three somehow are all representing the change of phase from liquid to vapor. Condensation is the opposite of that, obviously, change from gas to liquid. Then we have sublimation. And I don't think many people know this, but sublimation is the change from solid to gas without turning into liquid. And the best example for this is your dry ice. Dry ice, carbon dioxide, when you cool it, it doesn't turn into liquid, it turns into solid. And when you put it out on a table that is warm, and the environment is warm, it doesn't melt. That solid doesn't melt. It goes through sublimation, and that means it goes from solid to gas directly. So this is the introduction to how we're going to now calculate the amounts of heat in the next 9 examples.